Thank you everyone for being here. This is actually the start of what we're calling Governance Week at a16z Crypto and the research team. We'll be having a series of talks about governance. They're going to get actually increasingly specifically about governance. Our very first paper is much broader, and then we'll be, with increasing specificity, going pretty deep into different governance questions in Web3 and beyond. Without further ado, I'll turn it over to our first speaker, Gerry Tsoukalas from the Business School at BU. Thank you, Gerry.
Thank you, Andy. It's great to be here. Very grateful for the invitation. And there's a reason why it's going to be increasing. And the reason I picked this particular topic is because last year, one of my co-authors was here, who was doing hardcore voting, information aggregation stuff that we've done together. And so I didn't want to overlap. So I figured I'd pick something a little bit broader. But I'm hoping to convince you that there are interesting links with Web3, with governance on the application layer, right? It's not so much potentially on the blockchain layer, but the upper layer. So we're going to talk about who controls pricing on platforms. Very, very quickly, I know that's it's a relatively short talk. So just to motivate this, tech companies care about marketplaces. And there's multiple reasons. One of the reasons I want to highlight, we can just skip most of the quotes here, just to the middle one. The reason is that it helps them diffuse the technology. Okay, so let me just quickly read it. It says in 2017, every tech giant made a big splash about their machine learning as a service platform intended to democratize AI by enabling companies less blessed with technical talent to partake in the latest breakthroughs. Nice language. Essentially what they're saying is small and medium-sized enterprises don't have the resources, the capital, skills to actually acquire a lot of the really cool tools that people are building in AI and blockchain and all sorts of technologies, including the people in this very room. Right? And so they see marketplaces as a way to diffuse that to these types, to the broader economy, essentially. So let me zoom in on one. And this is a snapshot of Microsoft Azure. We're going to get into the model right away, and this will help me motivate the model. Okay? So it's fairly simple. On the left here, you have a list of technologies that a user, a buyer might be interested in. There's AI, machine learning, there's blockchain down here, and all sorts of interesting things. Once you click on it, you get a list of possible vendors that are providing these tools that you can download, you can pay for, and you could either implement yourself, or you could, it's part of the package, you could actually get help on the implementation. And I know it's kind of hard to see, but there are a lot of different products here from a lot of different vendors, small vendors, very large vendors, vendors that are known, vendors that are not known, et cetera. It's a mix of things. And some of these products, like this chatbot, competes with potentially other chatbots. So they're substitute goods, whereas others are complements. For instance, NVIDIA down here is offering an optimization tool that you can then pair with an LLM chatbot to make it run better, et cetera, et cetera. So you have this variety. So I want to just take a step back together, thinking about the economics of these platforms. It's fairly simple. What are some of the things that, as a designer, we might care about? So you want to have a healthy system, and you want to have a lot of sellers. It's one of the requirements. And so you need something like free entry for people to come in. You don't want spam, obviously, but you want some sort of open platform. The products themselves typically, like I said, are differentiated. Right? So they're either substitutes, they're competing against each other, or the complements, so they can help each other out. And when we start thinking about, from design's perspective, what do we control? What does a platform control? Not much, right? Okay, I'll add a caveat. There are things that could matter, like user interface design, what font you're using, that might affect people, marketing budget, all sorts of stuff. We're not covering any of that, right? We're covering matching and pricing, which is typically what you look at for platforms, but there's not really any matching going on here, right? The matching algorithm is essentially that search filter that says, put in what you want, I'll show you, the sellers, basically. So we're going to focus on pricing. And in this particular platform, the way they monetize is through simple commission contracts. Really basic. It's what most platforms are using. They take a percentage. Anyone guess what the percentage is?
30.
How much?
30.
30. Anyone else? Just out of curiosity. I had no clue when I started looking at this. I mean, there is a right answer, but don't worry. If you're wrong, it's fine.
10.
10%? Okay. So they started with 20. It's pretty sizable. That was 5 years ago. It's down to 3 now. Why? Because there was a little bit of a mini arms race. Google got in, Amazon Web Services, so that drove things down, way down, okay? But they do make some money. The other interesting part, which is the focus of the talk, is the decentralized pricing structure, which just means, you know what, we're going to let people price their own products. That's it. We're not going to get involved. And that's what we're going to focus on. We looked at almost 100 different platforms out there in various industries, all over the place. And roughly speaking, you can categorize them in these 3 types of pricing modes. So what I just talked about is this model, the decentralized model. That's Microsoft Azure, Google's Marketplace, Amazon Web Services, all that stuff, and many, many others. There's a decent amount of platforms that use the opposite of that model, which is the centralized model that says, I want to control everything. I don't trust any of my sellers. So Uber is notorious for controlling everything, including the matching that we're not going to talk about today. But on the pricing side, not only do they decide how much fees to take from drivers, but they also might show different prices to the actual customers. Okay, and they're hoping that customers and drivers don't necessarily talk during the rides. There's other ones. OpenAI announced that it's likely going to be centralized, but their strategy isn't fully developed yet. Web3, probably what people are most interested in this room, is essentially the decentralized model where you remove the platform and you end up with a disintermediated model. A disintermediated, decentralized. It's a very long, let's just call it Web3. There's a long list of startups. I'll just focus on one in the interest of time, which is Jensen. It's a really interesting company. The reason I'm highlighting it is because I really like the way their marketing materials are going after. The protocol disintermediates cloud oligopolists like AWS and does not charge a margin, which means a commission. Okay? So they essentially allow buyers and sellers to transact for free. It's a pretty interesting model. Just a side note, if you're interested, it doesn't matter for the model. But what these guys are doing, I think, is really, really cool. They're trying to leverage idle compute on everyone's laptops. For instance, right now, you're not really using your laptops. You could potentially connect to this Jensen network and make some money. So other people can use it to train their deep learning models. Really interesting idea. Okay, so there are a bunch of research questions. You might think of other ones as well that we're looking at. Does the pricing structure actually matter? Okay, so you have centralized, decentralized, so what? Right? Does that actually affect, is it a first order question or not? Does it affect adoption and profits and things like that? And the second one, are there potentially better contract structures? So this one's not obvious because when I looked at all these platforms, without exception, they're all using commission contracts outside of Web3, right? All the traditional ones, whether they're centralized, well, centralized, it can be even more complicated, or decentralized, it's just these standard contracts that we all use in many, many aspects. And does the Web3 business model make sense? That was a question from Ethan. Here are the answers. Why? Because we might run out of time. So at least I'm going to give you the whole thing on this slide so you can take away something. So yes, actually it matters. The first order thing, whether you're doing centralized or decentralized, it matters quite a bit. There are potentially many reasons. There is one reason in the paper that we're trying to write that I think is kind of clear. And the trade-off, I'll just summarize it here, that we'll get into it in the model. It's a story of two different types of frictions that you worry about. When you're centralizing, it sounds like the right thing to do. You get control of pricing, if you're the platform. What you don't observe are people's willingness to work. In other words, concretely, you don't observe their costs, their opportunity cost, their real cost, etc. So there is information asymmetry, and Econ 101, that will create some frictions. You'll lose a little bit of value in your system-wide because of this friction if you're not using optimal contracts necessarily. That's on the one side. If you decentralize, now you give everyone control, which is the simpler thing to do. I mean, you can set up a marketplace pretty easily when there's no matching involved, and you give up pricing, there's not much to do other than choose your font, I guess, and write a little bit of code. So when you do that, it turns out that it alleviates the information asymmetry problem because people now can set their own prices, observing to some extent their costs or their willingness to join the platform and work. What you lose is coordination. And you can think of potentially two separate models. One of them is everyone is rational, all the sellers are rational, and they're self-interested, so they don't take into account what's good for the platform as a whole. And I'll show you, the math behind that. You could even think of a model where, not everyone is rational and automatically you get, potentially bad outcomes from that type of model, but we're going to stick to, rational expectations models for this talk. So it's a tale of information asymmetry frictions on one mechanism versus coordination frictions when you have the other mechanism. Okay? That's the whole paper, for the most part. It turns out the reason that you have these two trade-offs is because of the commission contract itself, which seems innocuous. It seems like the right thing to do, or the simple thing to do in general. But when you're using commission contracts, it turns out that neither of these modes are optimal across all possible types of different markets and competition levels. And I'll show you some graphs. So what can you do? Then we take a mechanism design approach and we solve for the optimal contract, which turns out I couldn't really find a name. There might be in the literature, maybe some of you might know it. We call it affine contracts in the paper. It's a tweak on the commission contract. I'll show it to you. We get there, and then does the Web3 business model make sense? Ignoring the tokenomics aside, let's imagine they don't monetize and they're altruistic. That's best case scenario. I'll show you that even in that scenario, it can fail when they're using commission contracts. Okay?
Question?
Yeah.
So like in the contract theory literature, sometimes, these pure commissions are justified on robustness grounds.
Yeah.
Like, I don't know if you've seen like Gabe
And
Carroll's
it will
work.
be more robust. I'll show it to you. Yeah.
Okay.
But it's not optimal.
Oh, well, it depends on your notion of optimal,
Yeah.
right? So robustness in the sense that it's like worst case optimal over information you may not
Yeah.
know, right?
Yeah,
So-
exactly. Yeah.
Okay.
But it's not, without that constraint, it's not globally
If you
optimal.
know all the
Yeah.
details of
Yeah.
the
Yeah, absolutely.
market thing,
Absolutely.
okay.
There's a literature review. I know it's a short talk, so I'm going to skip. It's also a little bit outdated. The only point I want to make is that there's a growing literature on this, as you can imagine. There's old literature, but it doesn't really answer the questions that we care about for Web3. So there's this new literature that's really looking at, especially at the application layer, how do you actually create these DAOs, govern them, which decisions do you put in a smart contract, how do you do it, et cetera. On the model side, the decision variables, I'm trying to keep everything in blue, and for those of you who are modelers or theorists in the room, and endogenous quantities are going to be in red, and everything else in black is just going to be an exogenous parameter that we fix. So this is one of the challenging parts of writing a paper like this. There's a lot of different players. There's the platform. So we're going to assume that they cannot directly observe private costs, but they can observe some distribution of costs. And they're going to set the contract terms, which is just a simple commission. Or in the mechanism design part of the paper, it'll be just some general fee that could be anything. The buyers, I'll come back to it in the next slide. They are in gray here in the picture, and the sellers are in blue. The sellers are free to enter. They offer differentiated service, which essentially means that either they're competing a lot because their products are similar, or they're not really competing a lot because their products might be very different. And they have, importantly, asymmetric private costs that I list out here. And then we look at the three pricing modes. So in the centralized mode, the platform sets the price, cannot observe the costs of these sellers. There's a single price for everyone, since it doesn't have any other information. I think the right way to think about this is that it sets the price for a given local market at a given moment in time, and then it could change that in the next period. So it's a one-period model, but it's not forever. Okay. Similarly here, decentralized, the agents themselves set their own price after they've observed their costs. So you have different prices here that the customers observe, and they make decisions about what to do. And then the Web3 model, it's the same as the decentralized model, but you remove the platform from the middle. Essentially, there's no commission, and you replace it by a smart contract, and you change the objective function that you're optimizing over. It's no longer to maximize the profits of the platform because there is no platform. So why is this difficult to model? Because we don't know how people behave, how they make decisions. You know, it's the usual stuff, right? So you have to start from somewhere. In the interest of time, you know, we start from this workhorse, linear quadratic utility model for how customers make decisions about consumption quantities, et cetera, et cetera. So it's very well known in economics, but it's for oligopolists. There's differentiation through this gamma matrix here. But it doesn't really help us very much for the platform setting. For one, in platforms, you have a lot more people, so you don't need to worry about discrete individual players necessarily. So it's not a good model. Also, there's follow-up work that shows that it's really hard to work with from Litvina and Sirkar in 2011, et cetera, et cetera. So we did a bunch of stuff, and I'm going to wave my hands a little bit here, even though this is potentially, from a technical perspective, quite interesting. We do a series of approximations. One of them is innocuous. It's just moving to continuous space. So sellers now are described by continuous distribution of costs as opposed to discrete. Then we have some mean field types of approximations here. You do all this, and at the end, you end up with a demand model. Okay, like Cournot, you know, Bertrand, these types of things. But it looks a little bit different than the usual ones, and I should probably spend a little bit of time talking about this one, because it's going to drive, you know, all the results I'll show you depends on one parameter in this model. Okay, so what does the demand model look like? I think it's intuitive, but let me know if it's not. So this is the demand queue that a single seller or agent receives, okay, on the platform. As a function of the price that they decide, P, which is a function of their cost, and as a function of some sort of aggregate metric across the platform. That's kind of a standard type of thing. Now, the aggregate metric, I'm going to use P bar. This is the average price across the platform. And so when you write this out, you end up with an intercept minus a linear term, which should be familiar, which just says that, you know, the higher the average price across the platform, the less customers you get. Okay, and it's modulated by beta. It's just a sensitivity parameter. So this goes in the right direction for the most part. What's interesting is this new term, which is a little bit new compared to most of these demand models that you find in the literature. And this model captures competition between the different agents on the platform. Okay, so how does it do that? Well, it looks at what the average price is across the platform and then compares the price set by this individual seller. So if the price is lower, you end up with less demand than another server who would have more demand than another server. If the price is higher, you end up with less demand. So customers are basically comparing, you know, they have an idea of what the average is in expectation, and they're looking at individual servers, how they're pricing their own things, their own products. And depending on how far away you are, you get either more or less demand. And the important parameter that modulates that is gamma. Okay, so gamma is how sensitive customers are to price differences in the market. Sometimes, for instance, you take an Uber, you're going to pay whatever, you don't care. Sometimes you take an Uber, you're very sensitive to the price, you can wait. Sometimes you're impatient, sometimes you're not. Right? So this is what this parameter gamma is capturing. And it maps to these products that are substitutes. That's the competition case versus complements. I'll show you that in the next slide. One last thing. Every paper uses aggregate metrics that are usually total quantities served or average prices, median prices, things like that. We changed it in the paper. We use weighted average price. Weighted average price means that you weigh by the quantities that are actually served. And this is a point of contention with the referees right now. Maybe you can tell me what you think. I'm trying to explain to them that this is more intuitive for the following reason. Imagine you're buying a house, you need to figure out where the market is. Do you care more about the listed prices or the transacted prices that just happened? I'm genuinely asking. Because transacted, is everyone on board with that or no? You care about both potentially, right? But the transaction prices have more information in them because a trade happened. So when you weigh by quantities, you can actually take that into account. If you don't, then you lose that information. You end up with all sorts of weird stuff. But platforms could use pricing as a gaming mechanism to post fake prices that they're not planning to serve and things like that. It opens up all sorts of weird behavior that we don't see in practice. Okay, So this is the whole model. The integrals here are just sums because the platform doesn't observe. Sorry, it's across the sums of all the costs across the whole market. But there's a cap potentially, which is that not necessarily every seller is going to want to enter this market. It's a free entry market, but it might not be worth for everyone. So we needed a parameter to take into account the fact that, beyond some cost, people will not want to enter. So that parameter is called C hat. So everything's going to be I'm going to fix beta for the rest of the the talk, and everything's going to be a function of gamma. Is it clear what gamma is, or not? Should we talk a little bit more about it, maybe? No? So high gamma means a lot of competition. People are very sensitive to price differences. Low gamma means they don't care about price differences, okay? One thing you might notice mathematically, it's kind of nice, but difficult at the same time, is that the Q depends on P bar. The P bar depends on the Q. And so you have this feedback loop. You have to be a little bit careful to make sure that the problem is actually well posed. Okay, it's not completely trivial. This is just an explanation of how high gamma maps to substitute products versus low gamma maps to complement products. We could skip this as I'm a little bit behind.
Question?
Yes.
So, you're drawing like networks on some of the slides like this, but like in the model, there's no network structure actually in the model itself, right?
No, we don't really need a network. We don't study the network topology. It's not part of the...
It's just everybody affects everybody, basically.
Yeah, it's not, there's no local, like local market, there's no geographical issues and things like those are all very important and interesting in practice, but this is like a first pass type of model at this question. So yeah, it's a good point.
Is there any reason to think, my instinct is that the network structure might bias even more in the direction you're imagining. Is there any reason to think it might detract from the qualitative conclusion?
Which direction am I thinking about though?
Oh, sorry, more towards the separation you find between when centralized works and when Web3 works.
Right. I don't know, actually. I haven't thought about it. I have an idea, but I might be wrong. So I prefer to keep it to myself. Here's some math. How do you solve this problem? So in the centralized case, it looks quite easy. So the agent, individual seller has a profit function that's quite simple. It's their price minus their cost, that's their margin, but there's a part of that that's going to the platform. That's what the phi term is there. So that's going to the platform. So that's the per unit profit, and then you multiply it by the equilibrium demand that they receive, which was given by this function in the previous slide, which depends on P bar, which depends on the prices that everyone else is setting. There's no network structure, but you're definitely taking into account what other people are doing. And the break-even free entry condition is here. So if this is positive, it defines the marginal seller with a cost above which doesn't make sense to enter. The platform's problem is here. They set a single price P for everyone, right? So the platform controls here in the centralized setting. And they get some commission per unit, and then you just multiply by the total number of units, which is the sum across all the Qs, which are parameterized by all the Cs that are in the market, the costs that are in the market. So that's the centralized case. The decentralized case is similar with one big difference. There's no free entry break-even condition here. You replace it by the fact that each individual seller is solving an optimization problem over their own price function, P of C. Right, so they pick the best price that maximizes their individual profits. And then the platform's profit can be written similarly to before. So now it cares about the average price across the market times the commission, because it's the same commission for everyone. That's another simplification. And then you sum across all the actual quantities, but the quantities now depend on the solution to the previous problem. So this is like a Stackelberg type of situation where you first solve one thing and then you need to use that to solve the other thing. Right, so are these even well defined?
Sorry,
yes, go ahead.
The agents aren't heterogeneous, so in equilibrium, the average price,
They are heterogeneous.
They are heterogeneous.
Yeah.
Where's the heterogeneity?
It's the gamma. It's this thing here. Because it dictates to what extent customers care about price differences, plus the fact that their costs are different.
I see, okay. So those things are all indexed by some, okay.
It's not when you go to continuous space, you don't need to index it. You can just name it C, and it's a draw from a distribution.
There's one gamma or a distribution over gamma?
The gamma is fixed, which in practice, probably it's not.
So pricing heterogeneity is coming from these C's.
Yeah, the heterogeneity from the sellers
Yeah.
themselves have different costs.
Have different costs. So
But
we're gonna
we
say-
know what distribution
Yeah,
those
yeah, I got
costs
it, I
are
got it,
drawn
got it.
from.
Okay.
Yeah, that's what's creating some of the interesting pricing behavior here. If they all have the same cost, I think the whole thing kind of collapses probably.
I mean, I don't know.
Yeah.
It seems like the model would be virtually the same if they all had the same cost. You're going to have to choose a price, and
Yeah,
it's
but they would
just
all
going to be
choose the
bang bang
same.
instead of smooth. I
They would all
guess.
choose the same price.
Yeah, yeah, exactly.
So there would be no price dispersion, and price dispersion is one of the reasons that we get bad equilibria. But I'll show. But it's possible. Another thing I don't know, right? So I would have to investigate that. We should probably look into it as we're revising the paper right now. It's a good point.
But I guess, like qualitatively, there's a question of like, do the guys with high C's participate at all, right? Which
Yeah,
would require some
exactly.
non-trivial gamma, I would
Yeah.
think, right? It's kind of
Yeah, and so there are conditions under which you want them to participate actually, but there are many conditions under which you don't, depending on gamma. So just to try and move a little bit forward, there is a solution to all of these problems. And if you assume the distribution of costs across all these different sellers is actually just a uniform distribution, you end up with closed form solutions. If you don't do that, you don't have closed form solutions to these problems. And they're actually really, really simple and neat. I know the font is too small, you can't see it anyway, so let me just show you visually what the solution looks like.
so it's unique, or
It's unique.
okay.
Yeah, it's unique. There's always going to be three plots. Again, in the interest of time, let's just focus on platform profits, which is the first one always on the left. So here I'm plotting profits as a function of this competition parameter gamma, high competition, low competition, but I'm normalizing with respect to the optimal outcome under centralized pricing. So I'm going to call the profits under that equal to 1, and then everything else is going to be a fraction of that. And so the first thing you'll notice is that centralized pricing does not depend on gamma, this competition parameter. Why? Because there's just one price that everyone gets, so they cannot compete on price. Right? In a given market at a given moment in time, the sellers are not competing on price. Okay? Now, the blue thing is decentralized pricing. Now, you give control away. Now, everyone prices their own rides. They solve their optimal problem, and you end up with this blue curve where actually, on the edges, the whole market collapses. Okay, so why does it collapse? Is because they can't coordinate. They're solving individual maximization problems. It's a pretty classical issue in economics. You end up with coordination failures. There's a Goldilocks region here, which is a little bit counterintuitive and potentially interesting. It's the fact that by giving up control of pricing, the platform's better off in this relatively small zone. Okay, why? Because there's no information asymmetry in that zone. That's taken care of by giving up control, so you don't incur the information asymmetry frictions. At the same time, there's no coordination failures in that, not many failures in that zone. Even though they're self-interested, it turns out it works out fine. It's not a big problem. Okay. So the magnitudes are kind of significant. It's like 12% at the best possible case of decentralization. Not trivial, but they do depend on some of the parameters that we use, et cetera. What's the takeaway? So for me, the takeaway was, okay, it's nice that decentralization can actually help in some cases, but the problem is that competition is not a static thing. It's extremely dynamic, right? So this parameter gamma, I think Tim mentioned, is there a distribution? What's this parameter? It could change every day, potentially. What you can't change is you cannot go from giving control to sellers to taking it back. Impossible. Agreed? It's virtually impossible to switch. I'm getting 0 nods. Right? I mean, the burden you'd have to place on the sellers, like one day is like, okay, set your price. The next day, no, I'll set it. Yeah. Okay. So what can we do? We can try some mechanism design. A lot of people know if there are any people online or in the room that haven't done mechanism design, just a quick word on this. So we forget about the commission contract. We say, is there a better, what's the optimal contract? You search the infinite space of contracts. But there's one thing that can help quite a bit, which is the revelation principle. Essentially says, it suffices to ask people to tell you their cost. Just ask them. and then you make sure that what you offer in return does not lead, give them incentives to lie about their cost. In a nutshell, okay? So we're going to look at a mechanism where you ask people what their costs are. And then depending on what they say, you will say, okay, then this is the price you will set your product at. It's a centralized mechanism, okay? This is how much customers you're going to serve. This is how much fee you're going to pay me. You choose everything. The platform chooses everything. But the first step is tell me your cost. And so the way you write this up is you take into account the possibility that the cost reported to the platform from any individual agent might be a lie. They might say it's C tilde, whereas in reality it's C, not C tilde. So you write this up, the same types of stuff that we had before. It's a little bit different because now the platform has this generic fee structure, WC that I call it here, and it's trying to maximize the sum across the fees across all the possible agents in the market. And then these two constraints, the first one says that if an agent lies and deviates away from their true cost, they're worse off from an economic perspective. They make less money, but less profits. And the second one says that they should still participate. And so this would be a pretty standard mechanism design problem, the one you could open up one of those textbooks and kind of follow step by step how to solve it. That's what we initially did. The one caveat is that there's this endogeneity issue here. There's this P bar that depends on a bunch of stuff. So it took us a while to actually figure this out. But there is a solution for this as well, and it's also unique. And it looks like this. It turns out the optimal structure is not a commission, it's a quadratic function of your cost, right? So you reveal your cost to me, and I will tell you your fee is going to be a quadratic function with a bunch of parameters that depend on beta and gamma in the market. So how much competition there is in the market. Yeah, so everyone should use quadratic. That's kind of the conclusion, which is not a good conclusion, but let me at least show you what you get. So right now, the blue and the gray are the same as before. I just zoomed in a little bit. So it's centralized and decentralized. The green is this new contract that we identified through mechanism design. So what does it do? It removes all the coordination problems, and it gets you the maximum possible profit you could get for the platform. So if you do it, you'll get more profits, you'll get more supply, you'll get more customers served. Okay, but you can't really do it. I mean, I don't know it. If you know anyone that's using quadratic contracts for fees, I'd love to talk to you at the end of the seminar. So no one's using this.
So I just want to understand. So in this contract, as the cost goes up, the fee would get really aggressive. So like someone would double the cost.
So
and be charging like
I'm not
4x
entirely
the fee,
sure. Yeah, it's a good point, Tim. I'm not entirely sure because these parameters could turn negative. So it's not obvious to me that it's always that case. It's non-linear, so it could be weird. So here's how we went around that very quickly, because I see I'm running out of time. So what did we do? So you can't use cost. I don't buy the story of people revealing their cost personally. Instead, what we looked at are what are the other observables that people make if you decentralize. And you can observe the prices they're setting and the quantities they're serving. And so the idea is, okay, forget about asking for their costs. Let's observe what they do. And we're going to create contracts structured around the actions that they can take. And this is what we call these affine contracts. When they take an action xi that's observable to the platform, the fee is set as a function of that action. And it turns out it's an affine, linear, affine means there's this extra term here. So what actions can we observe? One, here's an example, we can observe quantities. And so the right contract in this context is forget about commission, let's observe how much you're actually serving, how many customers you're serving, and then the fee you're going to pay the platform depends on that. It's going to be, the amount of customers you serve times something, which depends on the level of competition in the market, plus a constant. So this is what we call affine contracts, for lack of a better word. It's a little different. So we looked at the literature. There's something called two-part tariff program contracts. These are a little bit different because this is on a per unit basis here. So on a per unit served, you charge something. Okay, so that is potentially more implementable. I looked around. No one's doing exactly this in practice, but there are versions of this that you might have heard of. Things like, hey, if you double your sales, I'll give you a discount. That's what this is saying. Right? Kind of. Okay, so how does this thing actually work, right? This, I think, goes back to Tim's question. How is it achieving these gains over these suboptimal commission contracts, et cetera? So what it's doing is it's affecting the incentives that each individual agent has to join or not join and serve customers. And so these are two different market situations. Let's just do the left one. These are the total fees paid by each agent as a function of their realized cost, which means that, let's say I'm an agent, my realized cost is 0.4. I'm here, this is the amount of fee I'm going to pay to the platform. However, there are negative fees, which means there's subsidies. So the optimal contract does wealth transfers between different types of agents. Some of them, you give them subsidies to encourage them to serve more customers, and you collect fees from others, and it can switch depending on what type of market you're in. If you're in high competition versus low competition, this thing can completely switch. So it's not at all trivial what it's doing. It looks kind of simple with the affine structure, but when you actually look at how it's doing and achieving all these gains, it's not trivial. You have all these subsidies and transfers. Okay, now, I know I'm going a little bit quickly here, but this is what you all came for, probably. What are the implications for Web3? I can't fully solve the Web3 problem because I haven't done the tokenomics yet. But what we can do are some first order things that are important, such as let's explore what Jensen is doing and all these other startups. Let's just set the commission fee to 0 and see what happens. But we can also solve for the optimal contract in this context without the platform by changing the objective to, instead of maximizing the platform's profits, we're going to maximize the collective amount of wealth that the agents are making. So that's this new objective function. Let's skip through it. It looks a little bit different than before. And the result is that it's the same structure that's optimal. So this affine structure remains even in this setting. The parameters are completely different. So the way you do wealth transfers might be very different between the different agents, but the structure is the same. And this is what it looks like visually. The green now is the optimal platform contract that you could either implement through the centralized quadratic cost contract, or you can implement it decentralized by observing the actions that they take, like the quantities and things like that. Regardless of how you implement it, these are your optimal profits as the platform. And if you're, let's say, a startup like Jensen, and you say, you know what, I'm going to compete against these platforms even when they're optimal, I'm going to use commission contracts. Sorry, I'm going to use 0 commission contracts without creating a new contract, so I don't take any money away. You end up with the same problem as before, where because people are self-interested, they're not coordinating with each other. So you're not resolving the initial problem that was there to begin with in decentralized pricing. Okay? So if you're just going to do 0 commissions and let people figure it out, set their own prices, it's not going to work for all markets. And the problem with startups, this is me taking a little bit of a leap of faith, is that you're not really in the Goldilocks competition zone if you're a startup. You're typically in the extremes. Like there's not enough competition usually, or you don't get enough sellers to compete with each other. That's what I mean. Okay, now if you implement the best one, right, the optimal contract with this, without the platform, you get the holy grail of Web3, all the promises that it's been doing from the beginning. You remove the intermediary, so there's more value to be spread out across the users of the system. You get a bunch of gains from that. And the fact that there are no more frictions, you get more gains from that too. And so you get this massive boost. If you could do everything optimally, 33% more profits, you double the amount of people that are serving the market, you double the amount of customers, so it's all the promises that we've heard in this idealized setting, basically.
So what's the difference between the optimal Web3 and the basic Web3?
Yeah, so basic Web3 is just removing the platform, but not solving an optimal contract. So the optimal contract does fee redistribution. So imagine a smart contract that for every seller says, okay, you set your price, but I'm going to charge you a fee based on how many people you serve, how many customers you have. That fee goes to the smart contract, gets redistributed to another agent. Okay, there should be no balance in the smart contract in terms of fees. It always gets redistributed out.
What does welfare look like for the sellers under the optimal contract versus the...
So this is it. Because there's no there's no there's no platform in the Web3 setting.
But
Right.
if
So this
there
is the
must be
sellers.
heterogeneity across the sellers in welfare from this contract, right?
Yes. So I think there might be situations where not every seller is better off compared to some other benchmark, but as a group they are.
It's like an interesting question about decentralized governance, about whether or not you could implement this contract by
Yes.
both.
I think I have some slides in the appendix, but I'm not going to have a lot of time to go over them. So just to wrap things up, so there was a question about tokenomics. So what this paper is missing is I've shown you a potentially optimal contract. You can buy it or not buy it. You know, we could do some robustness checks and all that kind of stuff. The question is, how do you actually implement it? What's the role of tokenomics in implementing that in practice? I don't know the answer to that. That could be an interesting thing to do. We have an older paper here that looked at this, I think the question that was raised at the beginning, which was, you know, how do these people make money, right? How does Jensen make money and other startups like this? And it's a question of token retention versus commission contracts, which are, you know, used by non-Web3 platforms. And so we find in this paper, it's a different model though. We find that commission contracts are actually better from a profit maximization perspective compared to token retention. Token retention is worse, but it actually leads to better service levels. It means you get more sellers and more users on your platform, even though you're giving up some profits as a founder. Commission does not dominate universally because there are situations where token retention can actually help, you know, under moral hazard. And so there are situations where you might want to use both in the paper. It doesn't happen very often, but it does happen. And the limitation of this paper is that it doesn't take a mechanism design approach. So ideally, what would be nice to do is to merge, you know, some of the lessons learned from this mechanism design paper together with, you know, some of the things in this paper that deals with tokenomics, and try to actually bring these things together and, you know, potentially help startups with some recommendations. Okay? So just to recap, does the pricing structure, it's the same slide as before, right? So does the pricing structure matter? At the very least, I hope I've convinced you that the structure kind of matters. And there's this core, you know, economic trade-off between information frictions, coordination frictions. There might be other things, you know, but in this paper, there's just this, okay? Neither one is optimal. You can do better by exploring new contracts. Something that we call affine contracts seems to work quite well. And in terms of Web3, you need to be careful how you implement it. The way most startups are doing it right now, you know, it's you're exposed to just market failures, basically, because if you don't coordinate people, even though you get this extra boost because you don't have commission to pay to anyone, it still doesn't work, right, on the edges. So you have to be a little bit careful, but there's a lot of promise there. Thank you.